we are still talking about inequalities. This section will not have any set or interval notation. We're talking about compound inequalities, which is this. Is this? What is the correct grammar? Compound inequality means two or more at the same time, okay? And they will be joined, or they're separated by an and or an or. That's a compound inequality. Two or more inequalities separated by and or. We're going to talk about or inequalities for the first part of the lesson, and then and for the second part. And this is on your quiz Thursday. So get with me in tutoring tomorrow morning or Thursday morning if you don't do well on the homework. So to solve a compound inequality with two separate inequalities using an or, this is what you do. You solve both inequalities, okay, separately. No big deal. What's different is how you're going to determine your solution set for that compound, or when you take both of them into consideration at the same time. It says your solution set should include all values that satisfy either inequality. This is like union of sets. This is like union of sets. Because if it satisfies one or the other, then it's everything coming together into one solution. And I'll repeat that again when we actually do a problem. That might have meant nothing to you right now, but it'll make more sense in the context. So here we have an or compound inequality. It's a compound inequality because there are two of them, and it's or because it says or. The first thing you want to do before even thinking about the entire problem, just one at a time, solve those inequalities, okay? So we're going to do that. For the first one, I will distribute the -3. You can divide it. I'm just going to distribute because that's what, just to be consistent with what we've been doing. What on earth? I got the calligraphy. So distribute. So that's -3x minus 6 greater than 15. Add 6 to both sides. So -3x is greater than 21. Dividing by -3. And this is where bells should be going off in your head. I mean, not literal bells. When you divide by a negative number, you flip the sign, the inequality symbol, to the other direction. If you forget to do that, you will change the outcome of your answer. And then solving the right side inequality is the easiest thing you're going to do today, unless someone asks you your name. That might be the easier thing, but for now, this is it. So what's going on here is I have two inequalities. In the last lesson, I would have just graphed everything less than -7, and I've been done. But this has another layer. And before I even can graph these on the number line, what I'm going to do is sort of graph them individually underneath the number line. So that way I can see them separate. I don't want to overlap them just yet. So here's what I'm going to do. For x less than -7, if I was graphing. So let me put some numbers down. 7, -6. So all the values less than -7 are here. So I've just done a baby number line underneath the answer number line. That's x less than -7 right here. And x less than or -2, I'm going to put that underneath so we can see them separately, or sorry, +2. So here's 2 over here. The equal bar right here means that 2 gets a bracket. And everything less than that. So there's the 2 pictures that I'm considering for those 2 separate inequalities. What I end up putting on the number line is the union of those 2 things. The final answer on the number line has to represent anything that satisfies this one or that satisfies the other one. Well, if you think about it, they kind of overlap right here. They both have those 2 things in common. So any number I pick there will satisfy both of them. So I'm going to go ahead and sort of shade that in right here. I know that those things in red work for both of them. But or means you're bringing all of both of them together in one bigger answer. So any number on this side satisfies x less than or equal to 2. So it has to be part of my answer solution. So all of this gets shaded all the way up to 2, the bracket. That thing that I just put in red on the number line, that's my answer. Those 2 black number lines that I put underneath, that was my work or my thought process. Those were not my answers. The red thing is the answer. If you pick any number on that red line, it will satisfy either the first inequality or the second one. And there's one weird thing going on. Like you might say, oh, in that first inequality, we said that x cannot be equal to -7. So she shaded it. Pretty sure she's wrong. She is often wrong, but she's not wrong this time. Because -7 doesn't satisfy this one, but it does satisfy this one. So it's okay to have it shaded on your answer. Does anybody have questions about that? You can put that in the chat. Okay. That's for or. I'm going to talk about quickly if this had said and. So if you weren't, so what I'm about to do is sort of right on top of this, but it's not actually part of the problem. It's just a different situation. If this had said and instead of or. And means satisfies both of them at the same time where they intersect. And that answer would have only been this. This is what the answer would have been if this was an and inequality instead of an or. Because it has to satisfy both at the same time. It's like an intersection, an overlap of those 2 black lines that I put on there. But the red one is combining them both together. So having said that, now we're going to talk about the and. So this is the bottom left of your notes. To solve a compound inequality with 2 separate inequalities using and, you still solve both of them. But your solution set, and by solution set, I mean that the shaded number line that we're working on. Your solution set should include only those values that satisfy both. There is no, and if there is no overlap, your solution is the empty set. This is like intersection. And inequalities are like when we just talked about intersection. Only where they overlap, only what they have in common, not all of it put together into one bigger answer. So here we have two inequalities joined with an and. The right one's faster to solve, so I'm going to start there. You divide both sides by -3. So on the left, I have x. On the right, I have +2/3. But remember, because I divided by negative, that symbol flips. So I now have x is greater than 2/3. And then on the right, you can do this a few different ways. You can multiply by an LCD right now. I'm just going to start by moving the 5/6 over first. So I'm going to add that to both sides. That gives me 2/3 x less than or equal to 5/6. You could multiply both sides by 6 to get rid of the denominators, and then divide by 2. I'm going to combine those in one step. To undo 2/3, you multiply by its reciprocal, which is 3. So those numbers cancel on the left, leaving you x. And on the right, when you multiply fractions, you go across the top and bottom. 15/12. And then simplify. You can divide 3 out of both of those. So I really have x less than or equal to 5/4. So I'm going to do the same thing as before and graph both of those on their own practice number line underneath the answer number line, because I don't want to mess up that just yet. And by the by, if you don't know how to graph 5/4, you can do 5 divided by 4 on your calculator, and it's 1 1/4 or 1.2. And 2/3 is 0.6666666 forever. So we'll just do about 0.6. So on my number line, I'm gonna put some numbers down. I'm gonna sort of spread them out. I'm gonna put 0 here. Dang it. 0, and I want space for my decimals to breathe. So instead of doing 1 on the very next line, I'm gonna skip and put 1 here. I'm gonna put 2 here. So the first inequality, the one on the left, is all x less than or equal to 1.25. So 1.25 is about right here. I have a bracket because there's an equal bar. And I need everything to the left. So this is x less than or equal to 1.25 or the 5/4. And then for the second inequality, I want all x's greater than 0.6. So here's 0.5, 0.6 is just a little bit to the left. So here's my 0.6, and I want everything bigger than that. So this is x greater than 0.6, or the 2/3. What I'm going to put on the actual number line for my answer or my solution is where those two things overlap or intersect. That's what and means. It has to satisfy one and the other at the exact same time. So if you look at where they're intersecting, where they have this, they share values, it's right here. So those segments are what is going to go on my final answer for my number line. On the left, it's the bracket at 0.6. And I'm sorry, the parenthesis. And on the right, it's a bracket at 1.25. And then it's everything in between there. That tiny little red stuff, that tiny little interval of red shading, that is my answer to the entire problem. That's the solution set that satisfies the compound inequality. It satisfies both the left one and the right one at the exact same time. And I have a question for you. What do you think this would have looked like on the number line if it had said or instead? And you can put that in the chat. If this had said or instead of and, how would that have changed the answer, or how would that have changed what I shade on the number line if it only had to satisfy one or the other? And look at those two black lines to help you figure out your answer. So if this had been an or problem and it only had to satisfy one or the other, which means I take all of the black thing, the top black line, and combine it with everything on the second black line, what that would have meant is this. Everything would have got shaded. Basically meaning all real numbers, all solutions. Okay, so that's just if it had said or. When it says and, it's just the red part on the number line, not the blue part. Okay. Does anybody need this up anymore, this screen? For the last two problems on this, on the back of your notes or the second page, these are still ands, but they look different. Like I said at the beginning of the lesson that compound inequalities are two or more inequalities separated with and or. But this thing looks like one inequality, and I don't see an and or an or anywhere. I submit for your consideration that this is a compound inequality. You see there's two inequality symbols. So it's like two separate inequalities. It's like this one is one, and this one is one. 2 less than 3x minus 4 is one section, and then 3x minus 4 less than or equal to 19 is the other section. So then you might wonder, okay, well, is this an and or an or? So I know how to do it. It's an and. It's just a different way of writing it. It happens to use the same expression in the middle that has the variable. So I'm going to go back to this slide real quick and just look at the steps. We are still going, so to solve a compound inequality written as one statement, we're still going to isolate the variable, but any operation you do to the middle, you must also do to the left and right side. And if you multiply or divide by negative, you reverse both of the inequality symbols. So let's see how that will go here. So looking at just the middle with the 3x minus 4, you're going to follow the same steps as if this wasn't here. Like if you just had 3x minus 4 less than or equal to 19, you add 4 and divide by 3. Oh, there's a question in the chat. Yes, it will always be an and for these kind. So you add by 4, divide by 3. And that's what we're going to do. We're just going to do it. We have 3 places to do that now instead of just 2. So we start by adding the 4 every the middle, the right, and the left. So now I have 6 less than 3x less than or equal to 23. I'm still don't have the x by itself. I have to divide by 3 everywhere. The left side, the middle, and the right side. So that gives me 2 less than x less than 23 thirds. And this one's very easy to graph because we're just going to take this and sort of like pop it up just like it's written here is how I'm going to put it on the graph, just with shading. Although you might be thinking, I don't know how to put 23 thirds on a graph. Just divide it real quick in your calculator. 23, you put the 23 in first, and then divide by 3, and you would get 2 less than x less than 7.6 repeating. So you just throw some numbers up here. The 2 and the 7.6, neither of those have an equal bar. So that's when we used to give open circles. We're not doing open circles anymore. We're doing parentheses. So I need everything between 2 and 7.6 repeating. Everything shaded there. And that's it. You try the last problem, please. And put done in the chat when you finish so I know how far along we are. So you please do the last problem and put done in the chat when you're done. Oh, I've been recording this. Let's go about this last one. Oh, I'm sorry, I didn't have it up there. No, I mean, I try to have the new problem up there for people who are handwriting their notes, but nobody said anything, so hopefully that was no big deal. All right, so compound inequality, we need to get the x by itself. So I start by subtracting 1.4 everywhere. And maybe you did that tip we learned last week about multiplying everything by 10. That's okay too. So on the left, this gives me negative 9.6 less than negative x less than negative 2.3. And now the thing is that x is negative, but I need it to be positive. So if you think about it as times a negative 1, then maybe you divide everything by negative 1. And it has to be done all 3 sections. So that changes to positive 9.6, positive x, and positive 2.3. But it also has to flip your symbols. So when you divide by negative number, the symbols flip direction. And so if that's something you forgot to do, it completely changes what your final answer is. Well, it makes it illogical is what it does. It makes it something not true. So then to go graph it, just throw yourself some numbers down. Notice something. If you're on autopilot and you're not stopping to think, 9.6 is not on a number line to the left of 2.3, even though the way my answer looks, it is on the left. What's really going on here, if you flip this entire thing but preserve the symbols, 2.3 needs to go on the left on your number line, right? So this is still, if you look at the x, it's still bigger than 2.3 in both directions. So your brain has to make that connection before you go to graph. So we'll just put 2.3 here. I'm running out of time, so I'm just going to fake it. I don't even know if I'm going to put the numbers in the right spot. I should probably put the numbers in the right spot. 3, 4, 5, 6, 7, 8, 9. What is it? 9.6. Because the moment I try to rush, people get upset because they get confused. So then it's between those two things, but there's no equal bars. So it's all parentheses and then shaded in the middle. So your grade for today is the homework from the first lesson. This homework from this lesson is not for a grade, but you are still responsible for the material, okay? Y'all have a great day. Yes, I can stay behind if you have a question.